Equation Wiki. Limiting regions. Chapter 12. The limiting region will limit the amount of product that forms due to insufficient number of reactions. So the limiting region is like the thing that prevents more products from being produced. The excess region is the opposite. That's when you have more product. You have extra, you have like a surplus of it. So a good example of both of these is if you had taco meat, but not enough taco shells. The taco meat would be the excess region, and taco shells would be the limiting regions because they are limiting the amount of tacos that you can make. Taco meat allows you, it's in surplus, you have like extra of it.
Theoretical yield is the max amount of product that can be formed from the given amount of reactants. Actual yield is the amount of product that is actually formed in the reaction. Like theoretical yield is the amount that you think you're going to have with like all of the products, but in reality you don't get everything, which is the actual yield.
So the percent yield is the ratio of the actual yield to the theoretical yield, and it's like expressed as a percent. So percent yield equals actual yield over theoretical yield times 100, and then you should get your percent yield.
Go.
Now we're going to do a real problem on what is the limiting region when 80 grams of copper reacts with 25 grams of sulfur. So first I like to write down what is known and what is unknown just to clear up anything that you might not think. So what we know is the mass of copper, which is 80 grams, if that's given. And then the mass of sulfur is 25 grams, that's also given. And then we know that 1 mole of sulfur equals 2 moles of copper. So the unknown, we don't know the limiting region. That's what we're looking for. So first you have to set up the problem using dimensional analysis. What you're looking for is moles of copper. And we have 80 grams of copper times 1 mole of copper over 63.5 grams of copper. Then these cancel, and you end up with 1.26 moles of copper. The next thing you have to do is convert mass to moles for the sulfur. So you have 25 grams of sulfur times 1 mole of sulfur over 32.1 grams of sulfur. This is the molar mass. And you get 0.779 moles of sulfur. The next step is to convert moles of copper to moles of sulfur. So we have 1.26 moles of copper, that's up here, times 1 mole of sulfur over 2 moles of copper. And we end up with 0.630 moles of sulfur. And this is the needed amount, the least amount we can have. So you end up with 0.630 moles of sulfur. That's the least amount needed. This is less than 0.779 moles of sulfur, which is the actual amount you have. So you have more than what is required. So that makes copper the limiting region. Sulfur would be the excess region. And that's how you find that problem. So now we have another problem dealing with limiting regions. So the problem says, what is the max number of grams of Cu2S that can be formed when 80 grams of copper reacts with 25 grams of sulfur? So again, we're going to write down what we know, what we don't know, just to clear out our thoughts. And we know that the limiting region is 1.26 moles of copper. We know that 1 mole of Cu2S is equal to 159.1 grams of Cu2S, and 1 mole of Cu2S equals 2 moles of copper. Then the unknown is the yield. How much are we going to produce? So first we have to convert moles of copper to moles of the product. And we write 1.26 moles of copper times 1 mole of Cu2S over 2 moles of copper times 159.1 grams of Cu2S over 1 mole of Cu2S. And again, things cancel, and it's set up like a dimensional analysis problem the regular way, and you end up getting 1.00 times 10 to the second grams of Cu2S.
I'm going to talk about how you can find the theoretical yield of a reaction. So we're going to start with calcium carbonate, which this is a balanced equation of calcium carbonate, and it reacts with heat, so that's why there's a triangle there. Some of our knowns, we know that the mass of calcium carbonate is 24.8 grams, and 1 mole of calcium carbonate equals 1 mole of CaO, and we are going to try to find the theoretical yield. So first, you start with the mass of the reactant, and then we're going to convert it to moles. So here's the mass, and then convert it to moles. In 1 mole, there's 100.1 grams of calcium carbonate. So so these cancel out. Then the next step, which you would add on to this, is we're going to convert the moles of the product to using the mole ratio. So you already know that these cancel out. And then in 1 mole of calcium oxide, there's 1 mole of calcium carbonate. So that means this would also cancel out. And then the last step would be converting from moles to the mass of the product. So we're just adding on again, so these all cancel out. And in 1 mole of calcium oxide, there's 56.1 grams of calcium oxide. So this would also cancel out. And then we would solve it by, so 24.8 times 56.1, and we get 13.9 grams of calcium oxide, which is your theoretical yield.
Go.
Since you gotta be
Yeah.
careful if we
Go.
Okay,
packs, it's
so
gonna
back from
feed back
Casey's
into
problem,
the
this
device.
was the
Okay, all right.
theoretical
So you
yield
really
that we
good.
figured
He said
out
you could end up
was
frying your laptop or your iPad.
13.9
Oh wow.
grams of
Plus, he said
calcium
my
oxide.
phone was already charged.
We're calculating the
He said
percent.
you gotta. He said when you hit 100%, you really
And
need to take
we
it out.
know
'Cause
that the actual
will start to
yield
feed back
is
as well. Okay, great.
13.1 grams
So
of
I think I
calcium
might have a
oxide.
little more.
So you put the theoretical yield, which is 13.9, over the actual yield, which is 13.1 grams, and then you multiply
I
it
took
by
mine out.
100%,
That's
you
red hot.
get 94.2%.